Okay, so continuing on with structural beams, you can place columns also in 3D. Now, when you're placing columns in 3D, pay attention to this 3D snapping mode. Now, you can do this with all different kinds of structure, not just with columns. And what you can do is you can start at a certain location, and then as you go upwards, you can snap to the top of a column. So this kind of allows you to sort of draw columns on whatever angle is needed, and it tends to blur the distinction between a column, a beam, and a brace. So that 3D snapping function isn't just available to columns, it's going to be available to beams as well. So we're going to look at those objects soon. Now, in terms of the kinds of columns and the kinds of materials that you have to build structure in Revit, here, while I've got the column tool activated, if I go to the Load Family button, I can go down to the Structure folder and load up a structural column. Now, while you are using the Structural Column tool, Revit will only allow you to load structural columns. If I went into the structural framing, lost my mind, tried to load in a beam that would be used as a column, Revit will give me grief. So here Revit's saying, you can't load in a beam while you're working with the structural column tool. So back to square one. So I got to go back to my Imperial folder and then down to structural columns. So here you can see the different kinds of columns that are available: concrete, steel, precast, and wood. So those are the different flavors of structure that you have available. So if I want to do something like a wood column, you can see I've got different kinds here, so I could bring in a glulam column of some kind. So here we're in Western Canada, so we can use the Western species and choose the size of glulam column that we want to use. So now it's loaded, it's available for use, and I can, of course, swap out one of my existing steel columns for the glulam column I've just loaded. So now I have a 2.5 by 9 inch wood glulam column. So let's move on to structural beams. Now, when placing beams, I will often do it in 3D. So the columns I will often put in using a plan view, and then the beams I will often put in 3D. And here's why. When I'm using the beam command, I will often use 3D snapping. Boy, does this make short work of putting in your structure. All I have to do is draw from column to column. You will see a circular snap. It's kind of got a little star in the middle. That's the point snap. And if it says point or end point, it doesn't matter. It's going to snap from the end of this column to the end of the next column, and there's my beam. So I'll go over to these next columns here and put those in. So now I've got my beams spanning between my columns. Now what I'm going to do here is I'm going to add a few more columns, because we're going to talk about beam systems in a few moments here. So actually what I'm going to do is I'm going to go into 3D and I'm just going to get rid of everything here, and I'm going to start from scratch. So in my level 1 plan view here, with all of these grids visible, I'm going to put in steel columns. I'm going to put in steel columns here. And I'm going to use the vertical column with the at grids option. And remember that when you're using the at grids option, you probably want to do a crossing selection. That's from right to left. So start on the right hand side and go across to the left and select all of your grids. So now when we go look at it in 3D, there's all of those columns. And the reason that you're seeing this blue thing over here, by the way, this is a reference plane that we had before, and I used the set work plane to switch to that working plane, and then used the show command on the architecture tab. So I use set in conjunction with show. We will see that again tonight. So as we were talking about earlier, the sort of the preferred workflow with structures to put the columns in first, and now to put in the beams, again with 3D snapping. So I can just start going from column to column. Now you'll notice here it does not do what you would call a chain. You folks know if you can go click, 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 click with walls and put in a whole bunch of walls at once. So each time one beam is put in, I have to choose the same starting point again to draw the next one. So there's that next click, and then click, click, to place all of these beams. So I'm going to put in a line, 2 lines of beams here in 3D. There. And we're going to talk about the 2 different kinds of beam handles. Now beams can be placed on grids in plan. You can see that in page 2 there in the notes. I like the visual confirmation of what my beams are doing, so that's why I will do my beams in 3D rather than drawing them in plan. That I'm not sure why that may be. It may be the order with which you draw them. Also, too, when you draw a beam, I think if you span it over top of another column, it may cut that column back. So not so here. You can also click a column, and just like you attach a wall to a roof, you can attach a column to a beam. And now you can see that column is sitting fully underneath the beam. Yeah, so I'm not sure why if all of your settings here are the same, it could be that your columns simply are not coming up to the level, so they might be too low. I'm not sure. So there's something probably just in the settings that are different between you and me when we're placing these columns that causes them to be columns to be under the beams rather than coming up to the top of the beam. Yes. Okay. So why would our beam not show on the plan? Anybody want to take a guess at that one? So here, if I go to my level 2 plan view, nothing. Anybody want to take a guess? It's really simple. It's your view range. Yeah, it's view range. So what's happening is your view range looks right down to level 2, just to the level. Well, the beam is just coming right up to that level, so not shown. So even if we take the bottom of our view depth and make it -1 inch, have to do the same with our view depth as well. And by doing that, now you can see we get the physical lines here. Now you can see with the line weights, again, there you go. At the coarse level of detail, your beams are going to appear as a heavy line. Like if you want to see their physical size, you've got to switch to the medium or fine level of detail, and now you get to see that beam. Down the center of the beam, you're seeing the dashed line. That is for the flange. So that allows those beams to appear. Now, there's a whole bunch of settings when you're putting a beam in place. So once you've got the beam tool activated, if you go over to the properties palette, you can see there's a whole bunch of different settings for when you're drawing these beams. Now, your Z justification, so that means the line that you draw, does that represent the top of the beam, or the center of the beam, or the bottom? Now typically we draw it so that line we draw is the top of the beam, but you can set it to be something else. Your Y justification is along the line that you draw. You can see the different options here. Origin, left, center, right. Now the origin of the beam, I believe, is along the structural, what they call that thing, not the modulus. I can't remember what it's called. But if you've got a C channel, there is a sort of a centroid of the beam, and so that origin point would draw that line along the centroid. If we choose the center, then it draws it at the physical center line of the beam, and then left and right. So if you're placing a C channel and you got, say, an HSS2, and you want that C channel to sit right along the side of the HSS2, you can set it so that location line that you draw is at the back of the channel, so you can place it nicely. So what you'll do is you'll draw that first C channel, kind of see where you are, and then maybe you've got to flip it. So when you're placing a C channel, you can hit the space bar to flip it so the flanges are on one side or the other. Now there's also a Z offset value, so that if you want to raise or lower the beam, you can do so while you drop it. Now just while we are on the topic of steel construction here, for those of you who are not familiar with steel construction in terms of how it's done locally, usually what we have in steel building is it'll be with concrete decking, or metal deck with concrete inside. So you have metal deck, typically 1.5 to 3 inches for the depth of the steel itself, and then usually 2.5 inches of concrete cover goes over top. So you have 2.5 inches minimum thickness of concrete, and then maybe another 1.5 inches for the deck itself. So you've got 4 inches from the top of concrete to the bottom of the deck. Now, this floor system will then, in turn, sit on a steel joist that itself has kind of like a little I-beam at the top of that joist. So if you were to look at this joist from its side, you would see this, and then there's webs underneath it that help with the tensile forces that are inside it. And then these open web steel joists, this thing here is called the seat. And this seat has varying thicknesses. I think, what's the tip? Is it 5 inches, I think, is a common seat, or 4 inches? So let's say that you've got a 5-inch seat on your open web steel joist. And then finally, this open web steel joist is now sitting finally on a W-shaped beam, which carries this whole business.
Holy smokes, I'm totally out of scale.
So here, we might more like this. Now it'd be a little L angle, a steel angle at the side, and there's your concrete layer on top. So this thing is 4 inches, this is 5 inches, and so now your beam, in terms of where it sits from the level, is down -9 inches. These joists are down -4 inches because they are at the underside of the metal deck. So when you are putting in your structure in Revit, it might be helpful as you are putting in the structure that before you draw it, you already put in a negative value for these beams. So I can put in -9 inches. And now I can draw it here, so I'm already ready to be at the proper negative elevation for when the rest of the structure goes on. So we're going to put open web steel joists on top of these beams. Those are going to be dropped 4 inches to be below the deck. So you can see after the fact here I can grab all of these beams and change their Zed offset value here to -9 inches. Now, just to make things even crazier, you'll notice above the Zed offset value there is a start level offset and an end level offset. And these work in conjunction with our Zed offset value. So here, now all those beams have been given a 2-foot vertical offset at one end. So if you need to slope your beam to certain amounts, you can use the start and end level offset to control that slope if it needs to be numerically driven. If you need to make it flat but raised or lowered, then I use the Zed offset value to facilitate that. Now, when you are drawing a beam, most of the time, I presume they will be straight. But you'll notice that when you're using the beam placement tool, that you have other options. So you can draw curved beams, and you can even draw a spline-shaped beam. Rip your budget. You're not probably cost-effective. So here, if I use one of these other tools, it means that when I draw this thing, it's just like drawing the regular arc. You do your start point, you do your end point, and then you draw the radius that you want. And so here we're getting a very expensive and possibly not even made curved steel beam. Now, if you want to, say, do like a curved glulam beam that's going to be put in a roof, that's certainly plausible. It's done all the time. And if you need to do that, now we need to draw the beam on a reference plane, just like we did with that column, drawing it on a reference plane. So what I'm going to do is I'm going to go to a plan view, so you could do this in your roof plan view or in any one of the other plan views in your project. And you could start by drawing it on a reference plane, if that's the correct location for this beam, or elsewhere. So here, by again using the reference plane tool, by placing a reference plane and then giving it a name, we can draw a beam on that work plane. So there's my reference plane, which I'm now going to name. And so now I'm going to look at that reference plane from my west elevation so that I can place a curved beam on this plane. Now, as you'll see, I'm also able to use any one of these grid lines that are perpendicular to the direction of the view. So if I'm in the west elevation and looking across my screen, any one of these grids would do, or this reference plane. Okay, so here I'm just going to set my level of detail to medium so I can see all that stuff. So we used the Set Work Plane tool on the Architecture tab to set us up for putting us on the right working plane for this beam. And so out of the Set Work Plane dialog box, you can choose any of the grids that are perpendicular to your view direction or that reference plane. So now I can use the beam tool and use that curve option. So now I can do my curve. Oh, I don't have my glulam loaded, so I better load one up. So I'm going down to my structural framing inside the beam command so I can load up this glulam beam, structural framing, wood, glulam western species. So I'll go down and get a big one here. All right, so now I can draw this big glulam beam curving over my project. Holy mackerel, that's a monster. So now when we look at it in 3D, There it is. So there's that big Glulam beam. Now, if you need to put that beam at regular intervals in your plan, you only need to create the first one. After you have created the first one, which I guess is here, you can use the copy command and you can copy it sideways across your plan, no problem at all. So here, if I need to put them at 12-foot centers, I've got the multiple option on. Just drag it to the side, 12, 12. Or I could use the array command as well to place as many of these things as I need in my project. So there's all my beams all laid up. I could have used one of those grids. So here when I select this beam now, you can see I can change its work plane after the fact. So I hit edit work plane, and now I can move it to, oh, it's not going to let me move it to A. Oh, here, pick new host. Do I need to be in a plan view? I might need to be in a plan view. Well, first of all, I will show that in the west elevation view, if I'd used the set work plane command, I could have used that first grid, which I think was grid A. There we go. So having done that, now I can use the beam tool and place it on a curve. So I'll just make a different curve here so it's easier to see. It's there. This bigger glulam, as you will see, is on grid A. So I didn't really need to create that reference plane. It was quite happy enough just being placed on that grid line. So now I can copy it across after having placed it on that grid line quite freely. Okay, beam end handles and shape handles, top of page 3. Now, beams come in different flavors. Now, I was mentioning the open web steel joist. I'm going to load one of those in right now so we can see what those look like. We've already got our beams dropped, ready for them to be placed. So when I fire up the beam command here, I'm going to go straight away to the load family button. And I'm going to back out to my structural framing folder. If you don't know where you are, just find US Imperial and go from there. So then down to structural framing, and then steel, and down to, I'll just use maybe the K-series joist rod. And I'm just going to pick one of these, maybe an 18-inch deep joist. So I'll just scroll down. Doesn't matter which one of the 18s. You just make sure that you don't pick a joist that's so large, and I'll mention this now. These open web steel joists have built-in arrays inside them to array the webs. And what can happen if you use too big a joist for the span, that Revit can't create the array. So let me show you what I mean first. So here I'm putting in the -4 inches, so it's below the concrete and deck, and I'm going from here across to the other side, and I think I can do a snap perpendicular, SP. No, I can't. Okay. So there's the open web steel joist. Now, something's a little funky here. It's not sitting at the right elevation. Oh, that might be because I miscalculated the depth of the seat. It's probably only a 2.5 inch seat, so this thing is sitting 2.5 inches too low. So instead of -9, it should be -6.5, -6.5 inches. Is that right? Anyways. So there's my joist sitting on it. So what I was saying is, if you put in an open web steel joist, let's say I put in like a 42-inch deep joist here, if Revit can't create at least 2 of these webs in there, the joist can't be placed, and Revit will start complaining at you. So just keep that in mind. Now, top of page 3, beam end handles and shape handles. Some structural objects have 2 sets of controls. The dot handle is called the beam handle. That is the one that actually changes the length of the beam. And there it is there. The angular controls change the non-structural length of the beam. And in the case of an open web steel joist, typically you will drag them outwards to create a longer seat. So sometimes you can, okay, now it's not working for me. Why, Revit, why? It should be just working right here, working fine. You silly thing. Nope. Start extension. Well, maybe this is it here. Why would this not work? I gotta. You know, well, sure, now it's doing it. Okay. I have to check and see if my families are messed up here, but those handles there are supposed to drag the non-structural end of the beam. And now you can do this with one of the steel beams that you see here. So you can see there's the end dot, the circular dot, which changes the structural length of the beam. But if you drag those diagonal handles out, you can see how the steel beams get longer. So the purpose of this with an open web steel joist, those controls are meant so that you can extend the seat outwards if you wanted to maybe cantilever that seat out a little bit beyond its support, so you can put like a parapet at the end of it so you can have a roof overhang. So that's the purpose of those controls. So shape handles and beam handles. Now you saw me sort of struggling to get this one joist placed on top of these beams. Now if I wanted to, I could go into a plan view here, and in this plan view I could use the beam tool and grab my steel joist that I've got here and draw it from one to the other, like so. And I could draw it and place it and draw it and place it. And that would be tedious, especially if it's a regular joist spacing. So yes, I could just place them, oops, and copy them over like I did with the beams, right? So I could just grab this first one and use the copy command and copy it at the frequency that's in the structural design. Not a good use of your time. There is a tool set that Revit has developed called the Beam System tool, which will quickly get beams placed in a certain area of your project. So this is it right here, the Beam System command. Now beam systems are a little bit odd in that you cannot create what we would call a type-based set of joists. Now if you think in wood frame construction, everything's at 16 inches on center. So in a wood frame situation, we load our 2x10 joists, and in here, inside this palette, when you've got the beam system command started, you can choose 2x10 joist, fixed spacing of 16 inches, and go up here, hit edit type, and call it 2x10s at 16 inches on center, right? And then you can just pick all the different joist types, 2x10 at 16 inches, 2x12 at, 12 inches, whatever. But no, you cannot. The beam systems are all one-offs. When I go into edit type here, there isn't really anything. So it means that whenever you do a beam system, it is going to be a one-off, but at least it is fast. So here's the process. First of all, you choose the structural member that you want to be used in the beam system. So beam systems are meant for creating a set of regularly spaced same member beams. So again, like a series of joists all in a row. So there is our open web steel joist, set a spacing of 7 feet. And now what we do is we draw the area within which the beams will span. So they're going to span from these beams here on grid 1 to these beams on grid 2, all the way from grid A to grid E. So you've got these pick tools. There's the one support, there's the support on the other side, and I'm going to use the pick tool now to draw the rectangle within which these joists will be placed. So just like any sketch in Revit, it's got to be closed and non-intersecting. So I'm going to use the trim tool to trim this into a rectangle in this zone here. There we go. So I've got that rectangle there. Now you folks will notice there, that one pink line there has a set of double lines on it. So there's like 3 lines all side by each on that bottom sketch line. That's telling you the joist direction. Well, that's not the direction we want our joists to go. So hit the beam direction tool, and now you can choose one of the other sketch lines to indicate that that is the direction that you want to go. Now, if for some reason neither of those are the direction that the joists are supposed to go in, and you need to put them on a bit of an angle, you can use the beam direction tool, and instead of using one of these pick tools here, you can draw a line that indicates the direction that the joists are supposed to go in. So starting from that line, Revit would space them at 7 foot on center. You can see all the different kinds of layout rules that you have here: fixed number, maximum spacing, clear spacing, fixed distance. Choose what you will. And then choose your justification and so on. So I'm going to delete that line now and specify a beam direction using the pick support tool. So, oh yeah, there's no beams there, right? Okay, so that's the direction of our joists, and hit OK. Now that the joist system is in place, there it is there, it's on the wrong floor, so we'll fix that in a moment here. So beam systems can be selected by putting your cursor over the edge of that pink box that you drew earlier. That selects the whole beam system. So here I can select it, and now I can go back and edit its properties. So you folks can see I could change the joist, I could change the spacing, I can choose or edit the justification. Now what I want to do is edit the work plane here, and I want to move it up to level 2. So there's all my joists up at level 2. And earlier we talked about how they need to be dropped 4 inches because of the concrete. So my elevation here, I will put in -4 inches. So that drops all of my open web steel joists down, and then I can put my decking on top of that. Now, if you have a situation where you need to maybe just modify the spacing of one of the joists, or just move it over slightly because maybe you have some mechanical equipment, or maybe there's an opening that's going in the floor and you need to move one of those joists over, you can do so. So again, if you put your cursor at the edge of the beam system, you can select it, and that means you can edit it, change its size, right, just like a regular floor object. But if you need to make a change to one of these things, just to adjust its location, or maybe even just adjust its size, if you put your cursor over the individual members of the beam system, you can select one of them and you will see a pin tool. If you unpin it, now you are free to move that individual member, or delete it, or change its length, or whatever. So as soon as that one member has been unpinned, now I can copy it, or I can move it. So here I'll move it over 6 inches. I wouldn't be able to do that unless I had unpinned it. And now I can copy it over. So now I've got a double joist. So if I needed that for some reason, I could, I think I can just copy something without having unpinned it. Yeah, there you go. So you don't need to unpin it to copy it, but you do need to unpin it to move it. So if you need to put headers or something like that in for an opening, that's the method by which you could do that process. Now, if for whatever reason you realize, you know what, I want to undo these edits that I've made. I want to go back to my out of the box, my vanilla beam system that I had originally. So to reset it, what you must do is put your cursor at the edge of the beam system so you get that dashed line, select it, and then edit as if you're going to change the size of the beam system. Because within this view, you have the reset button, so you can put everything back to the way it was. So there you can see it's putting this joist back in place. There's 2 of them in place, so I need to delete one of them. And of course, it's not going to get rid of this copy that I made here. But now I can go in and delete those copies. Whoops, that was the pinned one. I'm just going to HH it so it's not there. There's the copy, and then HR to bring it back. Okay, so the bottom of page 3, that covers all that stuff. Inside the sketch, you can choose the reset button. Now, top of page 4, we've already put beams on work planes and beams in elevation, and we've shown you all of that stuff. So, one of the things that I'll just bring up here tonight, when you're working with the structural tools, often when we extend structure out into an overhang, especially when we're doing sort of this West Coast style, which is influenced by Japanese architecture, when I'm placing one of these glulam beams, often you'll see that when a glulam beam is extended into an eave, that we don't just leave that glulam beam. Oh, it's still on that work plane. So let me just draw it here. So when we extend a beam into an eave, we often don't just leave that beam straight cut. We will often do a little decorative undercut on an angle underneath it. Now, in our share out folder for tonight, we have a family called Glulam with end cuts. And just to show you folks what this looks like, I'll drag this into Revit here. Now, initially, when you use this beam, you might not see any differences straight away. So there's the other glulam, and it's in our session 3 folder. It's called Glulam with end cuts. But inside this family, there are a couple of check boxes. Where are they here? They are inside the type properties. Notch end 2, notch end 1. Actually, I'll just notch one of them. You'll see what happens here. There. It nibbled off the bottom of this beam. So if you are interested in seeing how this beam works, you can dig into it, and I'll tell you. We're going to be getting more into family creation in this course. And what you are looking at here is a couple of voids. Those orange things that you see are voids. Now Revit's modeling tools, they're rather basic. You can see the modeling tools up there on Revit. There's solid modeling tools, and then there's a void form menu drop down which has those same tools but voids. So when a void intersects a solid, the void cuts geometry out of the solid, and that's why we get that raked cut being placed in this glulam. Now later on in the course we'll be talking more about modeling solids and how they work when we're building, you know, desks and furniture and that kind of stuff. One of the features that you can do is that you can take a particular solid in a family and you can hide it. So I mean, just think about a door. We model a door so that the 3D leaf is in a closed position. But when we show it in plan, we show it open. So what we do is we can ask Revit to show geometry turned off in plan, making it invisible. Now, if we have a void and it's already here cutting a solid, you can't take a void and make it invisible. There's no functionality to do so. But what you can do is move the void away from the solid when you don't want it there, so you get the straight cut instead of the angled cut. So the little special sauce in this family is that this void is sitting on a reference plane that can be moved off the solid so it doesn't cut it. We'll talk about this later, and you can take this family home with you if you want to use it. All you need to know is that when you're using it in the context of a family, that there are the end cut check boxes here that you can turn on and off as you so desire. So braces, page 5. Now, what a brace is, really, it's just a beam. So you can span from a column and go up to a beam with a brace. So on the structure tab, when you find there it is, the brace tool, it does exactly what you expect. And typically you do place those with 3D snapping, going from a column up to a beam to put in those braces. Okay, the next thing to talk about here is metal deck. So we were talking about here with our steel construction how we would have a floor that would sit on top of these open web steel joists, and of course the flutes of the deck would be oriented perpendicular to the joists. So let's go to level 2 and let's put in one of these floors. Now you don't have to use a structural floor, you can use just an architectural floor. That will be quite fine. So I'm just going to use an architectural floor. Now, I'm sure you folks have put in floor objects before, and instead of using pick walls, I'm just going to draw a rectangle here, and I'm not even going to be that disciplined about how I do it. And I'm sure that in times past, you folks have seen this symbol in your floor sketch and just ignored it. And of course, it means the same thing as it does when we were making the beam system a few moments ago. This symbol means the span direction of this floor. Now, for an architectural floor, it doesn't really matter, but now it's kind of going to matter, because we're going to be showing you how these steel decks with concrete on top are created in Revit. Now, go through and look at one of the different floor types in the list, and you can see there is 3-inch lightweight concrete on 2-inch metal deck. Now, maybe I just haven't been around the sun enough times. I've never seen 2-inch metal deck. I've seen 1.5 inches, I've seen 3, and some other depths, but not 2. So it's a bit of an oddball. Whatever. Let's use this floor type, and we're going to talk about it now. So you can see there's a little preview there, and it looks like it's undulating at the bottom, just like a steel deck would. And what we're going to do is we're just going to finish this now. And so now we've got our concrete and metal deck, and I'll cut a section through it. So I'm going to cut a section right through our, no, I should cut them parallel to the open web steel joist. So I'm going to cut a section parallel to the joists, just to see what we see. Now we are at, again, the coarse level of detail, so we're not seeing a whole lot. Switch to medium, and lo and behold, look at that. I'll just switch the scale down to 1/4 inch here. That's pretty coarse. Looky, looky. That's pretty cool stuff. Okay. Is this 3D? Like if I put a camera underneath this deck and look up, what am I going to see all those flutes? So here I am on my level 1 plan view, and I'm going to use, from the 3D view, the camera tool, and I'm going to look up. In fact, I don't even need to do that. I can just go into my 3D view here, and I can flip my floor upside down and have a look. I do not see any flutes. There are no flutes. What that is a bit of two-dimensional chicanery that Revit is putting on for you. It is faking it out. So these flutes that you see here aren't really there, which is kind of even crazy when you think that you can see through the flutes and see the seat of the open web steel joist in the background, and the little bits that are sticking down are actually obscuring that joist in the background. So what's happening is Revit is actually using this more like a solid hatch pattern in this view, and it is indeed only two-dimensional. If we were to cut our section in the other direction, we would see a dashed line indicating the top of the deck, and we'd see the full thickness of concrete. So, at the very least, this does get you the appearance of concrete and a steel deck, but it's not actually modeling it, because that would be impractical. That would be way more polygons and way more facets for the model to show, and it could really have some performance problems in your software if that were to appear. So the process by which this little bit of magic happens is inside the type properties for the floor. So inside that steel deck, I'm sure you folks have all been to the structure dialog box for a floor assembly. So the reason that we get these undulations here is by adding a special function, and it's called the structural deck function, and there it is there. This structural deck function occurs because a special deck family has been loaded into the project. This deck family is not a 3D family. It is a 2D family that draws the undulating shape of the metal deck. So it looks just like this. It's a 2D shape, and it'll show the thickness of the deck, and then this module just gets repeated down the length of the floor. And as soon as you load one of these structural deck profiles into your project, that structural deck feature here in the properties palette, or in the structure dialog, becomes available. So that is how that works. So once you've added that structural deck, you'll notice now it never gives you a thickness. So what it does is it works with the thickness of the concrete that you put on top of it to provide a total thickness. So that's your 5 inches right there. The reason that we're seeing this much of a gap here is because the profile family, if you were to go and look at it, has this much of a lift inside it for its shape. So I would recommend that you folks dig into that so you get a little bit familiar with how that little bit of how that works within the software. And if you have any questions, just raise your hand and drop a like that you folks have been doing that so far. That is good. Okay, foundations. Now, foundations come mostly in two important categories that you folks need to work with. You don't have to worry about the slab foundation. We're going to look at isolated foundations and wall foundations. Okay, so first of all, isolated foundations. That means pad footing. So there's the isolated foundation right there. And you're probably not going to have one yet. So we need to load one in from Revit's folders. So what you have to do is go back out to your US Imperial folder. And from there, go down and find structural foundations. Inside the structural foundations folder, you must find the rectangular footing. Now you can see there's all these different kinds of pile caps for friction piles or bearing piles. If you're needing one of those, you can grab one of these and pull it into Revit. Most likely what you want is the rectangular footing. So this is a pad footing for a column. So now there is your pad footing. They are ridiculous sizes to begin with. So probably your first order of business after you load this structural isolated footing is to straight away go into your type properties and with your structural engineer's drawings in hand, get the size and depth that you need. So I'm going to do a 3 foot by 3 foot by 10-inch footing. So I'm giving the plan size and the thickness 3 foot each way by 10 foot or 10 inches deep. So length 3, width 3, thickness 10 inches. There we go. Now I've got a more rational size. With the isolated footing tool, you can put it, you see you can kind of snap it to the end of a footing. Where is that thing here? Oh, my columns, I was looking right at it. Okay. So what you can do, instead of just placing it sort of manually in plan, you can use the at columns option. And what you do, if you pick a column, see where it's going to put it? And now I'm going to hold down the control key so I can pick additional columns. And so now I can put pad footings at all of those columns. And when I hit finish, there we go. So again, once you're using the structure, isolated foundation, which is a pad footing, use the at columns option, and then you can just simply place it at one or more selected columns. And there you have it. Okay, wall foundations. So I wish they wouldn't call it a foundation, because a foundation really also means the foundation wall that it sits on. I wish it said footing instead of foundations, but whatever. So to use the wall foundation tool, you must already have a wall drawn. So here, if I've got, I'll just use generic 8-inch. So I'm just going to draw a wall. And now that that wall is there, I can use the wall foundation tool. And then what happens when I use the wall foundation tool is I just click on a wall and it gets a footing. Really, really handy stuff. So once you've drawn your concrete walls, dig in there and get those wall footings placed. Now, I'm going to just close all other views here. Let's go over to page 6. I've got some tips for you for when you are modeling structure. In the Session 3 folder, we have a tilt-up and steel framing file, which will allow you to sort of go over some of the tips that I'm going to be talking about right now. Now, I don't know how many of you have worked with projects that have sloped structure, but modeling that can be a little bit of a tricky exercise. So I'm going to give you one of the tips that I use when I am modeling slope structure, in particular steel. I worked for a company that did a lot of tilt-up construction. And I've done tilt-up projects even prior to that. It's a common building technique. It's low cost and it's quite durable. So here's that example file. And so in open web steel joist construction, what typically happens is you've got the concrete walls around the outside, and then your roof is held up by steel beams that are in the interior of the building. So you folks can see how that steel beam is going down for drainage, up, down for drainage. And the open web steel joists just follow the undulations of that center steel beam. Around the outside, typically with tilt-up steel, they have a pocket that the open web steel joist sits in. All those pockets are typically at the same elevation. And the open web steel joists sit at a lower elevation on the inside to sort of force that water to drain towards the low points. So with the structure, if you're kind of trying to draw that all in, what I've done to give these joists something to snap to other than the top of the wall, which I don't want. I want the joists to sit lower than the top of the wall because we want to have a little parapet there to keep snow and stuff from blowing off. So what I did is I drew a tiny little 1 inch by 1 inch HSS tube and I ran that around the perimeter of the inside of that wall. And there it is. So that's that little gray thing here is a 1 by 1 HSS tube. I draw that around the perimeter, and then when I'm putting in my open web steel joists, I 3D snap from this HSS tube, which is flat, and then bring it down onto my beam in the middle, which of course is sloping to follow structure. Now when I'm 3D snapping, I don't of course necessarily get my joists fully perpendicular to the edges. So what I do, after I've just sort of willy-nilly dropped some of these joists on, so I'll just to give you an example here. So I'm 3D snapping from the HSS tube, and you can see it nicely snaps to this, and I can take it out to my beam in the middle and snap it to that. So that's all great, but that joist is on some crazy angle. How do I get that straight? Well, in my roof plan, there's my wonky joist. What you're seeing here is a bunch of green detail lines. You see those lines? They're just 2D lines. So what I do is I get my layout from my engineer, find out the spacing he wants them at, and put a bunch of 2D lines in place so that after I've drawn my joist to snap from the HSS tube on the side to the beam in the middle, I can use one of these detail lines and use the align command. Now here you can see I'm at the coarse level of detail, so I'm only seeing a single line for the joist. That's at the center of the joist. So I can use the align command, pick the detail line, and then pick my wayward joist. And it just swings over into place. And when I go back and look at it in 3D, it's now running perpendicularly to the edge of the building, but it's still snapped in 3D to the flat HSS tube at the side, and to my sloping beam in the middle. Now you're like, well, are you going to see that 1x1 HSS in your views? Yeah, you'll see it in section, and nobody will notice it, little blip in your drawings, so it's no big deal. So that's part of the set of tips there that have been shown in the tips section there on page 6. We go on page 7. We've already talked about the levels of detail and how you can do the overrides. So what we're going to do now is we're going to go into the exercise on page 8. And I'm going to do this with you. We're going to end up, I think what we'll end up doing is I'll give you guys the instructions on how to do the exam, and you guys can do the exam anytime that suits you. So you can actually go home and do the exam as long as you've got an internet browser. You'll be able to log in. I'll write the instructions up on the screen. You will need to do a bit of work in Revit. Now, if you have pretty much any version of Revit at home, you can do it at home with whatever version of Revit you have. So you have to do a topo surface. If you remember last week we used the graded region tool and we put in those extra points. You're doing that again, but this time for marks. So maybe the best way to do it would be to do that part of the exam here tonight, and then you can do the rest of it later. And once you've got those numbers, just write them down, put them on a piece of paper, text them to yourself, whatever, so you can fill in the blanks. The exam doesn't require you to submit a file. It needs you to get numbers from Revit and put them in the blanks. So if you can get that sorted somewhere, you're good to go. Okay, so let's do this wood frame exercise. The starting file for it, again, is in our session 3 folder. And it is called the Building 2805 Structure Exercise. Now, the purpose of this exercise is to show you kind of how these structural tools work, how you copy them, how you edit them, how you place them on weird angles. For any of you who do a bit of heavy timber construction, this is probably some of the more advanced modeling that you would do. So we're just basically building like a little, not like a pagoda, but a little, like in a park, a covered area that would have exposed structure inside it. Okay, that wasn't it. Well, it's a structural wood framing exercise, for crying out loud. There we go. Okay. It's called the structural wood framing exercise. I should actually read my own notes. Very top of page 8. So we've got some posts, and we've got a floor that's just some joists with wood decking on top. So the first thing that we're going to do is step 1. Use the structure beam tool and choose the 5.5 by 15 wood beam from the type selector. So here's structure, here is beam. On the options bar, choose 3D snapping and draw the 4 beams as shown, spanning the length of the building. The beams will pass through each other. So you start from this corner here, and you go all the way over to the other corner. And you're just going to work your way around and draw all 4 beams. And I'll just turn on shading here, SD. Okay, so step 2, after the beams have been placed, so I'll hit escape a couple of times to get out of the command. Select all 4 beams, Control, select all 4 beams. And in the properties palette, set the start and end extension to 4 feet. So there's start extension right here, start extension and end extension, 4 feet for each. So if you just put in 4, that will do it. And then hit the 2 check boxes there to notch those 2 beams when they extend, and you can see the result. Confirm that the beams extend and are notched. And indeed they are. Okie doke. So, where are we at here? Step 3, open a south elevation view. Now, if the beams aren't selected, oh, I just did the wrong beam, rats. I used 2 by 10 full sawn. It should have been 5.5 by 15. There they are there, 5.5 by 15. There, fixed it. Okay, if all your beams are selected like you see here, you're good to go. If they are not, right click on one of them and choose select all instances in the project. So they are selected, so this is step 3. Move the beams upwards by their entire depth so that they sit on the columns rather than being embedded in them. So that means use the move command, and now you got to move them upwards. And move them upwards so your click point is from the bottom of the beam to the top of the beam. So this moves all those beams upwards so that they're sitting on top of the posts instead of being underneath them. So when you look at what we've got so far, you've got this. The beams are sitting on top of the columns instead of being embedded in them. So I'm going to go back to the south elevation view here. Now remember when I made that beam before, I had a reference plane, I drew the beam on that elevation. We're going to do that same thing here. Step 4, use architecture and then set. On the architecture tab, the set work plane tool is far over on the right hand side. So we're in the south elevation view. We've gone to the architecture tab. This is step 4 on page 8. Go to the set work plane tool, and in the dialog that appears, choose grid D. It's probably already done for you. All right. So now we're going to go to the structure tab and use the beam tool. And we're doing 2 by 10 full sawn beam. There it is, 2 by 10 full sawn beam. Ensure that 3D snapping is unchecked on the options bar. So here I'm going to uncheck it. Now why is that? Well, what would happen if we 3D snap to this roof is that Revit would snap to wherever this 3D point is, which is where those 2 eaves intersect at the corner. And then it would come and snap to the middle of this roof here. So your beam would be on like some crazy angle. So by unchecking 3D snapping, now we're forcing it to stay on grid line D. So we're going to draw a beam that goes up to the underside of the deck and then back down. So what this is built of is we've got wood decking with shingles on top, cedar shingles. So now we start at the eave, and this is the crazy thing. I don't know why this happens, but every year it does. See, it snaps to it there, but I don't want 3D snapping, so I turn it off, and now, see, it snaps to nothing. So Okay, what are we going to do here? So I'll use the pick tool. So go up into the tool set here and use the pick tool, and now we can pick the underside of the roof. You're like, well, what are we going to do here? Okay, so now it works. Do you guys have that same thing happen to you too? Yeah. It's one of these things where I need to go find a programmer in Manchester, New Hampshire, and beat him with a stick, because like Revit doesn't have very many bugs, but this one's been bugging me for years. So you use the pick tool, you pick the underside of the roof, it can't create the beam, like can't create period. Huh. I want what they're having, because that's some strong weed somebody's smoking there. So use the line tool now and it works. So we can snap from the eave up to the peak, and then I can snap from the peak down to the eave. Now what you want to see happen is that you want it to be mitered. So when two structural objects are drawn in the same plane and they interact, Revit miters them, which is nice. Now what we want to do is we want to create that sloped rake on the end of our beam. So select one of them now, and you might not know whether, well see that's the wrong end, so I need to check the other one. So play with the notch end checkboxes until you get the notch at the appropriate ends. That's what you want to end up with right there. So just so you folks can see where we're at so far, that is the step that we're at right now. We've got that first set of rafters created, and we're going to copy the rest of the rafters presently. Step 5, page 8. Open the underside of beams ceiling plan. So here in your ceiling plans, find underside of beams. And here's what we've drawn so far. Now we started at the south elevation. So there's those first two rafters we've just drawn right there. So ceiling plans, double click on underside of beams. And what we're doing here, of course, is we're looking up and we can see the underside of our roof. There's the wood decking above. And of course our rafters are going to span perpendicular to the decking. Step 5, select both beams, control pick the other beam here, and use the copy command. You know what, I'm going to do the array command instead. I'm going to do array. And I'm going to do it at 6 foot increments, so I'm going to click anywhere, drag up, hit 6 for 6 feet. Then Revit asks how many copies we want, and it says 5 copies. So now I put in 5. There, done. Anybody want me to do that again? Guys all with me? Awesome. Okay, over to page 9.
What was the distance between the...
Pardon me?
What was the distance?
6 spacing, and then 6 foot spacing, and then 5 copies. Now this is where it gets kind of tricky. Page 9, step 6. Okay, using the set work plane tool, which is on the architecture tab. So grab the set work plane tool. Now what we're going to do is we're going to choose pick a plane. So this allows you to select a plane of something in your view. So look as you move your cursor from face to face, you can see which working plane you'd be choosing. Now these planes are sloping. So we're not just picking some flat surface, we're picking a surface that slopes from the eave upwards towards our ridge. Now I'm going to choose the left working plane here. So now anything that I model is going to be following this slope of this roof. It's going to be placed on the underside of this roof. So now, structure, beam, 2 by 10. So this beam, on whatever angle I draw it on, it's going to be following the underside of this deck. So watch carefully and then do it yourself. So I've got the beam tool activated. I'm going to do a snap override, SE for snap endpoint. Then I'm going to put my cursor here on the valley, and it's going to snap to the middle of my roof where all those valleys intersect. So SE, keep your cursor on top of that valley line, and now click. Now we're going to come down to the end. So your cursor's kind of out in white space here. Don't click yet. We're going to do another snap override, SE. And we're going to hold our cursor over top of this valley line again, and you're going to see it's going to indicate a snap that looks like it's off the edge of the roof. It is not. And you want that snap to be right on the valley line. Now, see there, it's actually snapping on the wrong side of the roof. We want to snap right on the center of that valley line. And it's our view range right now. It's the cut setting of our view range, which is causing our roof to be truncated. So that's where we want to go, just like that. Not like this, not like, I don't know, whatever else. Just want it to be there. And now you can left click. Now what in the world are we looking at here? Well, that is the 2 by 10 that we're seeing right here. Why is it not vertical? Well, let's have a look in 3D. Don't you folks do it, but you can just see what's happening. What's happening is that Revit is making the top of that 2 by 10, see how it's coplanar? Like the top of that 2 by 10 is actually mated to the underside of our roof. So it's legitimately placed. It did place it on that work plane. The problem is that we don't want the top of the 2 by 4 flush to the underside of the deck. We want it vertical. So after you've placed it here, what you've got to do is you've got to go back and in the orientation setting for this board, see where it says here, normal. That means it's against the underside, the plane. It is normal to, it is perpendicular to the underside of our roof. We need to switch it to horizontal. And now what it does, you can see what it's doing. It's made it so it's actually vertical, not horizontal. So after that 2 by 10 has been placed, switch its orientation to horizontal. It's going to go back to the ceiling plan again, and now we're going to do this whole process for the right hand side. So step 1, architecture set. We use pick a plane again, but instead of picking the left side, we're going to pick the right side. There. So now we're working planes on the other side of this thing. Structure and beam. So same thing, we're going to use the snap override before we even get started. SE. Hover our cursor over that valley and click. So now the second end of the beam, we go down to the other end of the valley. SE. Zoom in close, put your cursor right on that valley, and make sure you click to the right geometry there, not that one, which is kind of off here. It's even hard for me to snap to it, but you want the one that's right aligned with the valley. And again, it's normal to the underside of the deck. We need to now select that board and switch its orientation from normal to horizontal. Okay, now a little bit of cleanup here to do. Let's go to 3D. So go to View and then 3D. If you guys are wondering where the roof is, I've turned it off in the 3D view. So in your visibility, the roof is there. It's just turned off right now to help us do what we've got to do. Okay, first of all, let's talk about what's happening with this board that's in the valley. The contractor would not bring it down and extend it through this these other rafters here. So what we're going to do is we're going to use the extend command to trim back this rafter so it stops here on one of our regular rafters. So we're going to trim our valley rafter back to one of our regular rafters. So modify, and there's your extend command. So with the extend command selected, pick the face of your regular rafter, so you can see which face I'm picking. It's the one that's closest to us here. And we don't want to pick the top face, we want to pick the side face. So pick that, and then pick the valley rafter and it'll trim it back. So I used the extend single command. So now I'm going to go over to the other rafter here, pick the side face of it first, and then pick our other valley rafter and trim it back. So now we've got, unfortunately Revit doesn't do a nice job of mitering those two together in the center, but that's just the way it goes. Okay, so all we need to do now is we're going to mirror all this business to the other sides. Now we'll do this in the ceiling plan again. So ceiling plans, underside of beams, double click. So what you folks are going to do is you're going to pick, control click all of the stuff that we've made tonight. All 1, 2, 3, 4, 5, all members of the array. Our valley beams, pick those as well. Pick them all. So the next step is we want to mirror this. So of the two mirror commands, choose the one mirror by drawn axis. It's the mirror command that uses the pencil icon. So having selected all of these beams, so all the regular rafters and our valley rafters, you can see in blue here, make sure you've got selected what I've got on my screen, and then go and find the mirror by drawn axis tool. Come over to the midpoint of the roof here. You should see a midpoint, or it'll snap to the ridge, that's fine too. So that's your first point of mirroring. This is your second point of mirroring. So now it's done all the beams on the other side, and in 3D this is what you're going to see.
Did you do anything with it to
No. Not yet. I'm sure at some point Revit will have a cleaner way to miter them all together, because that's a bit of a joke. You know what? To be honest, on some years, I've actually found that this rafter and this rafter would actually miter together. So here, let's see if I can get so lucky. I'll just use the shift key and pull it back, and grab this one, and grab. See, look at the dot is kind of not even in the right place. And then I can see if I can get the trim command to trim this to this. You know, it's not bad. Better than nothing, so I'll try these ones here. Trim, trim. So it's cleaner, right? So you can use the trim command to make those four in the middle match up a little better, but it's certainly not like they're mitering on the other side. Alrighty, so I'm going to go back to the ceiling plan here. So what I'm going to do is I'm going to select all of the rafters that we've modeled, not the beams, but the rafters. I'll do it in 3D. I'll select them all here. So here I'm going to do this. Watch this. I've brought it down so I can see everything. Now you're not going to need to model, or you're not going to need to mirror any more of these guys in the middle. We've got all the ones that we need for those center rafters. So what I'm going to do is I'm going to control click all of my standard rafters. All of them. Just those ones. I guess there's 10 of them that we should have selected. So in 3D, I selected those 10 rafters, and Now I'm going to go back to my underside of beams ceiling plan, and they should still be selected. So now, again, we're going to use that mirror by drawn axis, and we're going to use the 45-degree trick. So I'm going to, and it doesn't matter, somewhere along this valley, use that as your starting point for the mirror, and just make sure that the line that you draw from there is a 45-degree angle. And now it'll just mirror it around the 45, and you'll be done, and you'll have all of your structure there.
Rotate copy works the same way.
Yeah, you can do rotate with copy too. Mirroring is a little bit easier.
So can you do that?
Sure. So what I did was I selected all 10 of our standard rafter arrays here. And then I went to my ceiling plan, underside of beams, and I used the mirror by drawn axis. And what I did is I went into one of the corners here where the roof meets at a corner, and then I just draw a line out at 45 degrees so it mirrors it around that 45-degree angle and does the rest of them. So when we look at it in 3D, this should be what you get. Okay, so you will hand this into your share in folder. Don't save it in. You have to copy it in because Revit does not allow you to save into your share in folder because IT has your folder locked down so hard that you can only copy in that file once it's already on your computer somewhere. So now we can turn the roof back on. And there's our roof and all the structure underneath it. So it's a nice little exercise to kind of show you a common scenario for putting in those rafters, for drawing a rafter on a valley, for switching that parameter from normal to horizontal here to get that board rotated into the right place. Okay, exam time. So what you folks need is the file that's in the root of the BLDG 2805 folder. So if you folks want to see what this file is called, I'm just logging into the BCIT network from outside. It's in our share out folder in BLDG 2805. So I'm just going to BLDG. Yep, share out 2805. And it's this one right here, sitemodel.dwg. So you can either do the last question in the exam right now and copy the numbers down, or if you have Revit at home, take this AutoCAD drawing home. So I'll just show you what it looks like. It's called site_model. Nope, it's right in the root directory of 2805. So right in the root folder of 2805, it's not in one of the session folders, it's right in 2805 itself. You'll find this AutoCAD drawing. It is called site_model. This is the one that you will use to do your exam, your quiz. Nope, it's not in any of the folders. It's right in the 2805 folder. So just go there with Windows Explorer, and you'll see it here. This is the one. So folks, the property line for this thing is this gray line that you see right here. There's the gray line for the property. So you're going to need to use the split surface command. You're going to need to put in the property lines using the property line tool, and you'll just be able to pick that gray line, which is the property right there on the screen. And of course, this has got polylines that have Z coordinates. So here in AutoCAD, I'm holding down the Shift key and the middle mouse button, and I can orbit just like I can in Revit. So you can confirm that those polylines do have Z coordinates in them, and you can do the exam. All right, let's show you how to get there. So open up your browser, and again, you don't have to do it here. If you want, folks want to do it at home, you've got until Sunday night to finish the exam. So you don't even have to do it tonight. If you folks want to just take off out of here as soon as I'm done yammering, you can go and do the exam at home, or you can do it tomorrow. You can procrastinate until the weekend when it will be raining. So if you like to do your exams in the rain, inside, like God intended, to heck with all this, go home, have a glass of wine, sit out in your patio and enjoy what's left of the sunshine before the rains hit, just in time for the weekend. So here's how you get there. learn.bcit.ca. So when you hit that, you'll have to log in. And so you should see a screen that looks like this. So use your BCIT ID and password and log in. Okay, once you've done that, at the very, very top of the screen, you'll find select a course. And out of that drop-down menu, what you want to find is our course ID. It is 59442.201820. 59442.201820. So once you've clicked on that, you'll get to this screen here. And what you need to do is go to the activities menu here and choose quizzes. So once you get into quizzes, you will find quiz 2. Here it is here. So just click on it and quiz 1 right here. So quiz 1, you can start on that and you can begin. You have 2 attempts. So you can give it a go one time, and if you think that you'll be smarter the next time you do it, you can write it again. So you have 2 chances to take a crack at it, and I will mark them both, and whichever one has the higher grade, that will be your mark. So learn.bcit.ca, find our course from the top here, 59442.201820. Navigate to activities, and then quizzes, and there's BLDG 2805, midterm 1, open book. So you can go through and do all those answers. And like I said, here's all the different questions. The practical exercise is at the end. So here's the practical exercise. So what you need to do is do all of the steps that's mentioned here and do the work, and at the end give me the cut, fill, and net cut and fill volume and put them in these 3 blanks. I know there's 4, don't worry about it. Just put them in. Yeah, put them in here. It doesn't even matter which order you put them in, I'll just recognize them. But maybe put the cut volume and then the fill volume and then the net, you know, all in order in these 4 blanks, and you'll be good to go. So that's the part you need to do in Revit. And it doesn't matter which version of Revit you do it in. If you've only got Revit 2016 at home, it doesn't matter. It'll still work. Okay, other than that, you folks are free to work on this. And like I said, you've got 2 chances to give it a go. So we'll do that now for the rest of the class. The class is, of course, officially over at 9:45, but you're welcome to carry on. So just remember, make sure that after you're done, hit save after you do your questions so it gets recorded. Your answers get recorded. So if you do a few questions here, you can hit save, come back at home, and finish the rest of the questions at that time. Yes? No, I think you can open it more than that. It just means at the end there is a submit button. So when you hit submit, that's 1 attempt. Okay? If you guys have any other questions, just or problems, just email me. I can give you guys, you know, extra attempts if something gets screwed up with the technology. But this usually works quite well. Okay, that is all.